Please turn on your camera. Oh, okay. Note this question in your notebook and start doing this one, please. Then we shall be moving towards a tough level question. This is the basic and the easiest possible questions. Yes, you. Farhan and Irshad, please turn on your camera. And who is this named with Safia?
Yes, sir.
Yes, Safia. Just a minute. Safia, is it you? You recently joined now?
Yes, sir.
Okay. Let's move. So, do you know that what are concentration terms? Concentration terms, mass by mass percentage. Do you know how to calculate mass by mass percentage?
Yes, sir.
Did we do this one in the previous class?
No, sir.
No. Okay, so here we have three concentration terms. Mainly the two are important, very important for the examination point of view. That is mass by mass percentage. Mass by mass percentage. And what does mass by mass percentage say? That is mass of solute divided by mass of solution into 100. As we know that mass of solution is also equals to mass of solute plus mass of solvent upon mass of solute into 100. Okay. Start doing this one, please. Then the first question, what it is saying that a solution has a total mass of 150 grams, contain 30 grams of solute. So what does it means? Yes, you, Safia, can you answer me the answer for this question?
Sir, I'm still doing.
You are still doing okay, do it. Astit, what's your answer for the first
Sir,
question?
20%.
20%. Okay, 20% is the correct answer. It's very simple. That is mass of solute is being given to you 30 divided by 150 into 100. You cut 10 with 10, you will get 1 and divided by, you will get 5. 3 ones are 3 fives are. And when you divide 5 by 100, you will get 20%. 5 ones are 520. So the answer is 20% for the first part. And let's move to the next couple of questions. As you know, do you know what is solubility? Solubility of a substance. Yes, anyone in the class? What is solubility? Solubility. So solubility, I have explained you. Solubility is the amount of solute, the maximum amount of solute, the maximum amount of solute that can be dissolved in in 100 gram solvent at constant temperature. Constant temperature. It is called solubility. Okay. And its formula is solubility is equals to mass of solute upon mass of solvent into 100. So this is the only difference here in the solubility and the sol. In W by W percentage, here we have mass of solution. And here in solubility, we have mass of solvent only. This is the main difference between the solubility and okay, understood? Yes or no?
Yes, sir.
So if
Yes,
I'm
sir.
having a question here, let's start doing this question. It's very simple and very easy as possible. Means this is the very simple question. Can anybody answer me this question? You done? What's the answer? Simple. It is very simple. Yes, you. Astit, what's the answer?
Yes, sir. The what's
What's the answer?
grammar,
This is a simple answer. That is 36 gram can be dissolved in maximum in 100 grams. So how much solute can be dissolved in 200? That is double of this one. 72.
yes, sir.
So what is saying here is that 100 gram, 100 gram, if a solution, if some substance, 36 gram, it dissolved in 100 grams of solution. So what does it mean? It means its solubility is given. Its solubility is 36. What do you mean by solubility?
So the maximum amount that can be dissolved in a
Fine.
100 gram of solvent at constant temperature.
Yeah. So this is the maximum amount of solute that can be dissolved in 100 grams of solvent. So that is
Good
36
evening,
gram can
sir.
be dissolved. Good evening. 36 grams of solute can be dissolved in 100 grams. So this is the actually solubility.
Yes, sir.
And that would be equals to X is asking. And if this is 200 in 200. Now the mass of solution is given to you. Sorry, mass of solvent is given to you 200 grams. So this and this will cancel out each other. This will goes to this side. You will get X is equals to 36 into 2. That would be equals to 72 grams. Understood? Note this question. This is the easiest possible question on this topic.
Sir, sorry for it.
Why did you join so late?
Sir, because I was having revision tests of chemistry, physics, and biology.
Okay. Yes, you Farhan. They thus I should give you send you an invitation or some request that you are keep your camera turned on permanently, okay? Understood? Let's move to the next question.
Okay, sir.
First note this question and then we shall start doing this. So note this question, please.
Sir.
Yes. Note this question first. Done?
Done? No, sir. Just 1 minute, sir.
Yes, Irshad, are you doing? Are you doing this question? Or
Yes,
are you,
yes,
have you
sir.
noted? Have you noted?
Yes, sir.
So how will you proceed this question? This is very simple and easy question.
Sir, 3.33%.
So this is very simple question. What is this? A mixture contains three components, that is 40 grams plus 60 grams and 100 grams of water. Okay, the total mass of solution is 40 plus 60 plus that is 200 grams. That is total mass of solution. If it is saying that 20 grams of water evaporates, so what is the actual mass of from this 100 grams if you start boiling it? So that is 20 grams of water evaporated. So this new mass of solution will be 60 plus an 80, that will be 180 grams. Now calculate the new mass by mass percentage of substance A in the mixture. So what is the new percentage? That would be of mixture A, of substance A. So what is the substance A? Substance A mass is 40 grams.
Yes, sir.
So you will write 40 upon total mass of the solution right now is 180 into 100. Okay,
Okay.
got it?
Yes.
Yes, sir.
And when you got it, you will get 20 upon, or whatever the answer you get,
Yes, sir.
you cut 0 by 0, you will get 2 upon 9. That is 200 upon 9. Okay. So done.
Yes, sir.
Yes, sir. Then.
Just a minute. Okay. Do this one.
So can you explain this question?
I should explain you this question that 500
Yeah,
ml of
yes, sir.
solution
Yes, sir.
contain 100 grams of solute. Means in 500 gram of solution, you have 100 gram of solute in it. The mass by mass percentage of this mass by volume. What is the formula for the mass by volume? Mass by volume percentage formula is mass of solute
Mass of solute.
upon
Mass
Volume of solution.
volume of solution
Solution into
in
100.
ml into ml and in ml into 100. Okay. Now, what is the mass of solute?
So
It is
mass
given
of solute is 100.
100 grams and the
Yes.
mass by mass percentage is 20.
Yes, sir.
Okay. So the 500 ml of solution contain 100 gram of solute
Yes.
and the mass by mass percentage is 20.
Yes.
If
Okay.
100 ml of water evaporates and 10 grams of solute precipitate due to saturation, calculate the new mass by mass percentage.
Okay.
So what it is
So,
saying?
so sir, first we have to calculate this, then we have to calculate the new mass volume percentage of solute, right?
So it is, yeah, it is saying volume of solution. So you know simple, if 500 ml of solution is going to have 100 gram of solute, so its mass by volume percentage should be 20.
Yes,
If
sir.
it is not given, it's okay. Okay, because you know that if you divide this one, 100 is the mass of solute upon 500 is the mass of the solution, sorry, volume of solution into 100. Okay, so you cut this 0 with 0 and you will cut 5 1 the 5 and 520 the 100. So it is 20. Nothing to worry about. This question seems to be difficult, but it is very easy. The language you need to understand. So if 100 ml of water evaporates, so you know that when evaporation takes place, only the solvent evaporates, solute does not evaporate.
Yes, sir.
Like for sugar solution, if you are having, so only the water is going to evaporate, but sugar particle will settle down.
Yes, sir.
So it is saying that if 100 ml of water evaporates, and 10 grams of solute participate. So solute 10 grams. So if you are having 100 grams of water evaporate, so what is the amount of new water evaporate? Then what is the mass of solution now?
So as a solution?
Yeah.
Yes.
So you know that if it is saying that 100 ml of solution, if 100 ml of water evaporates, now the how many ml of solution should be there? 400 ml?
Yes, sir.
Hmm?
Yes, sir.
Because it is saying 100 ml of water evaporates. Actually, water evaporate, but the remaining amount of solution should be 400 ml.
Yes.
And it is saying that 10 grams of water precipitate. So, sorry, 10 grams of solute precipitate. So the solute that is precipitate, that is not in the solution. Hmm? That is
Yes,
being
it is.
precipitated, so that is not in the solution. So if it is not in the
Yes.
solution, so now out of 100, how much it is? 990,
Yes, sir.
because 10 ml, 10 grams of solute has been precipitated. So total amount of solute initially we have 100. So
Yes, sir.
100 minus 10, 10, that is the amount that is precipitated, you will get 90 grams. So 90 grams is the mass of solute.
Yes, sir.
And the volume of solution is?
So volume solution.
The volume of solution is
400, sir.
400, 400 into 100.
Yes.
Got 4 by this
Sir,
one,
I
you got
got
20.
22.5.
What do you say?
I got 22.
22.5%.
Yes. Yes, sir.
Okay. So
20, sir.
initially it was 20. Now the new is 22.5%. Okay.
Yes, sir. Thank you, sir.
Copy this
Sir,
one,
I
please.
did not understand how you got 400 ml.
You didn't understand how I got 400 ml.
Yes.
What is saying? If 100 ml of water evaporates, so water evaporate means out of 500 ml of solution. Okay. If 100 ml evaporates, so how much it is? That will be 400, na? So
Yes, sir.
if water is only going to evaporate, na? That's why it write water, not the solution. Because whenever we are having a solution or sugar solution or any solution, okay. So during that time, uh, you need to understood that only the solvent or the water evaporates. What does not evaporate? The solute do not evaporate. So solution is having which is carrying both solute as well as solvent. Okay, so out of this 500 ml, if water evaporates, only 400 ml is going to remain in that. Okay, because volume is something. Volume and mass is different thing. That let me explain you one thing here that, for example, if you have 100, this 100 ml of water, okay, and you add 10 gram of sugar to it, and you dissolve it. What is the new volume of the solution?
Per 100 ml.
Yes, Yostir, what is the new volume of the solution?
100.
It will remain 100 because the 10 gram of sugar is going into its intermolecular space. If it get dissolved, okay, so it will
Yes,
remain
sir.
into it. It's still you, but the mass will increase. Like for example, if 100 ml weight 100 gram for water has density 1 gram, so 100 ml of water is equals to 100 gram.
Yes, sir.
So if I ask you the mass of the solution, mass of the solution is 110.
So it will be
Because
110.
110, but the volume of the solution remains same.
Yes.
Okay, and when we are, let's suppose this is 500 ml of solution, and here we mark 500 ml, 500 ml. Okay, now due to evaporation, 100 ml of solution get evaporated. Okay, and you mark here 400 ml, 400 ml. So simple, we can simple say that I know that only the water evaporate, but the volume is the occupying capacity. That now 400 means 400 ml. That the solution is occupying space, that is 400 ml milliliter volume, not the mass.
Your
Okay,
volume never decreases, right?
Yes, sir.
means volume you cannot say that, oh, if we are adding 100 if we are adding 10 gram of sugar to 100 ml of water and get dissolved, so it does not mean that the volume should increase. No, volume will remain same because it goes into the intermolecular space. It is just like, for example, just okay, let me explain you. Let the one is over. But the concentration will increase, na? Because only the pure water evaporated. Initially, initially this
Yes, sir.
500 ml was having 100 gram of sugar. Let's suppose now 400 ml is remaining.
Yes, sir.
So 400 ml is remaining. Let's suppose no sugar is precipitated. The whole sugar content is there. So we can simply say that 400 ml, okay, this 400 ml is still having 100 grams of sugar.
Yes, sir.
500 ml was having 100 gram, and out of this 500 only the water evaporates, so still it is 400 ml,
Yes,
but
sir.
the sugar will be still 100 gram because sugar does not evaporate.
Yes.
So 100 upon 400 into 100 we get 425%. So initially it was having 20%. When it is 500 upon 100 into 100, you cut it, you will get 20. So initially it was having 20%, but now when it is 400 ml there, 100 ml removed, so it will be
25%.
25%. Okay,
Yes, sir.
when the adhan is over, then notice. Okay, you done? So what we are saying here is that now initially the 500 ml was having 100 gram of sugar. Now if the water evaporates, only the water, now the 400 ml of solution is having 100 ml of water, 100 gram of sugar. So it is 25%. But since it is saying that 10 gram of sugar is precipitate, so if the 10 gram of sugar is getting precipitated, so it means that it is not participating in the sugar. The 10 gram of sugar is not participating in the,
Yes.
it is not in the solution. Okay, so we'll write 400 ml, sorry, the total amount of sugar now is 90 upon 400 into 100. Because out of this 500, 400 ml is being evaporated, and out of this 100 gram of sugar, 10 gram is precipitate. Precipitate means it is not in the soluble form. It get in the bottom. It is not in the soluble form. So you cut
Yes.
it, you will get 22.5%. Understood? Safia, are you
Yes,
there?
sir.
Yes, Ansh.
Safia,
Yes, sir.
so you understood?
Yes, sir.
Please turn on the camera. This will also clear your concept. This question is also going to clear your concept. Does everyone done the previous question and the solution too?
Yes. Yes, sir.
Yes,
Let's check how much this question you can do. Just try. I'm going to give you the 5 minutes. Please note this question first and then
Sir, what is KNO3?
potassium nitrate.
Okay, sir.
You done this one?
Yes, sir, noting it, sir.
So still doing.
Okay, do it. The solubility of potassium nitrate in water is increased by the solubility of potassium nitrate in water increased by 10 gram per 100 grams of water for every 10-degree rise in temperature. What can anybody explain me this statement, that what does it means from here to what does the statement means
Sir,
from here to here?
it means that the solubility of KN3 increases with the increase of temperature.
Yes, solubility. If you keep on increasing the temperature, the solubility will increases. And for
Yes,
every
sir.
10-degree rise in temperature, you can add 10 ग्राम more solute. Means
Yes,
अगर सपोज करो कि कोई एक सॉल्यूशन है जिसमें आप 10 ग्राम सॉल्यूट को डाल सकते हो
yes, sir.
एक पर्टिकुलर टेम्परेचर पर, मान लेते हैं 30 डिग्री टेम्परेचर पर, किसी एक सॉल्यूशन के अंदर किसी एक पर्टिकुलर अमाउंट ऑफ सॉल्वेंट में आप 10 ग्राम शुगर डाल सकते हो। आपने डाल दी, 10 ग्राम खोल दिया। अब वो कह रहा है कि अगर आपने 10 डिग्री टेम्परेचर और बढ़ाया तो आप 10 ग्राम और डाल सकते हो, यानी मान लेते हैं 25 डिग्री पर आपने देखा कि उसमें 10 ग्राम डल सकता है, तो फिर आप 35 पर देखेंगे कि उसमें 10 ग्राम और ऐड होकर के टोटल 20 ग्राम हो जाएगा।
Yes, sir.
फिर आप देखेंगे कि 45 डिग्री टेम्परेचर पर 30 ग्राम हो जाएगा। तो दिस विल increase actually as you keep on rising the temperature. For every 10-degree rise in temperature, you can add extra 10 grams of sugar to it. Okay, so it is very simple and very easy question. Please answer. It is the easiest possible question. Do it.
Yeah.
And what's the answer? Tell me fast.
Yes, sir.
You know that as we increase the temperature, that the amount of substance will increase, amount of solute will increase,
Yes, sir.
and as we increase the mass of solvent, like for example, in 100 gram you can dissolve 35 gram.
Yes,
So if I am having 200 grams, so I can dissolve double of it,
yes, sir.
70 grams na?
Yes, sir.
जैसे is in 100 grams, 35 at 20 degrees Celsius, 35 grams of solute can be dissolved. So this is very simple that if 35 grams of solute, अगर आप 35 ग्राम, does everyone in the class understand the Hindi?
Yes, sir.
Is
Yes,
there
sir.
anyone? Is there anyone who didn't understand Hindi? Yes, you Safia, you understand Hindi?
Sir, I didn't understand.
Yes, sir.
Oh, okay. Irshad didn't understand. So what I'm saying here is that for every 10-degree rise in temperature, when you increase the temperature for 10 degree, the more amount of solute can be dissolved. So it is directly
Yes.
proportional case.
Yes, sir.
More the temperature, more will be the solute can be added.
Yes, sir.
And as you know that if you increase the mass of solvent, like for example in 100 gram you can dissolve 10 gram of sugar, suppose.
Yes, sir.
So in 200 gram you can dissolve 20 gram.
Yes, sir.
In 300 gram you can dissolve 30 grams. So what it is asking here, it is asking, let's suppose we'll make a table for this one. And here we have three columns. Three columns. Here we have temperature. Here we have mass of solute, mass of solvents, mass of solvent, temperature, and here is the mass of solute. Now you notice at temperature, at 35 degrees of temperature, okay, the mass of solute is 100 gram. Okay, means how much, sorry, how much mass of solvent is there? 100 gram. In 100 gram, the mass of solute you can dissolve is, tell me, in 100 grams of mass of solvent, how much mass of solute you can dissolve? It is given in the question. That is, at, sorry, at 20 degrees Celsius, you can dissolve 35 grams. So
Yes, sir.
let's change it. So it is 20. So at 20 degrees Celsius temperature, you can maximum dissolve at 35 gram of solute. Okay. Now it is saying in the question that if the temperature, and you know that for every 1 degree rise in temperature, sorry, every 10 degree rise in temperature, you can dissolve 10 gram extra solute. So if the temperature from 20 changes to 60 degree, okay. So can you tell me that how much amount of solvent, and the solvent here, it is not, let the solvent is there. But if I'm saying that it is 100 gram solvent, at 100 gram solvent, then how much gram of sugar you can dissolve? If I take this 100, then how much grams of solute you can dissolve? Can anybody answer me this question? I keep the solvent fixed, sorry, mass of solvent is still 100 gram. But the temperature at 20 gram, we can dissolve 35. And at 60 gram, how much we can dissolve, how much amount of solute can be dissolved if every 10 degree rise in temperature result in 10 gram extra solute?
So 75.
75. This is very simple. That for 20 gram, you are dissolving 35. At 20 degrees Celsius, you are dissolving 35. If this thing is constant. So at 30 degrees Celsius, you can dissolve 10 extra, 35 plus 10. For at 40 degrees Celsius, you can dissolve 35 plus means 45. The both the sum is 45. 45 plus 10. Then at 50 degrees Celsius, you can dissolve 55 plus 10. And at 60 degrees Celsius, you can dissolve 65 plus 10. The total amount of solute you can, because you can dissolve is 65 grams. Okay, but it is if it is 100. If it is 100. Now, if instead of 100, if I took 250 grams, then how much solute you can dissolve? Maximum amount of solute, it is 60. It's still 60. But you know that if I'm changing this value and it is 2.5 times of 100, 250 is 2.5 times of 100. If you multiply it by 2.5, you will get this one. So you have to multiply this number also by 2.5 because you can add 2.5 times of solute to it, extra solute. So that would be 65 into 2.5, whatever, sorry, 75 into 2.5, whatever the answer you get, you will get the same amount of, and that would be 187.5 grams. Understood?
Yes, sir.
So,
Yes, you Safia, you understood?
Yes, sir.
Okay. So here in the question, it was saying that how much if you have, instead of 100 grams of water, if you have 250 grams of water. If it is 100, then you can dissolve 75 gram. But if you take the 2.5 times of this 100, then you can add 2.5 times of solute to it. This is very simple. For example, if you want to make a cup of tea and you added 1 tablespoon of sugar to it. So if you want to make 3 cup of tea, you have to add 3 times of it.
Yes, sir.
Next. Noted everyone this question?
yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay. In the previous class, we were discussing, okay, is matter around us pure?
Yes.
Let revise, is matter around us pure? Can you tell me that what is the main difference between elements, elements and compounds?
Sir, elements are not chemically bounded, but compounds are chemically bounded.
No,
And
elements also.
yeah,
In
yes,
elements,
sir.
like in
Uh,
H2, the two hydrogen atoms are chemically bonded.
yes, sir. Sir, in a compound two or more. Sir,
Yeah,
in
two and
compound two
more.
or
In
two and more,
elements
two
consist of only one kinds of
only one
atoms,
kind of element.
while in compound there are two or more different kinds of atoms are chemically
Yes.
bonded.
Yes, sir.
Next fast, tell me.
So they cannot be separated by physical methods.
They cannot be separated by.
Physical methods.
Okay. So they cannot be separated by simple physical methods. Elements too
Sir,
cannot be separated by simple physical
sir,
methods.
sir, compounds are arranged in fixed ratio.
Yeah, in compounds, elements are arranged in fixed ratio. Moreover,
Yes, sir.
in compounds, the compounds cannot be simplified.
Yes, sir.
Because they consist of one kinds of atoms, you cannot simplify them further.
Yes, sir.
Okay, but like for example, you have water. Water is a compound, and you pass electricity to it. So compound can be further simplified to its constituent by chemical methods. Okay, by chemical reactions. Got it? So hydrogen gas and oxygen gas can be split out from water. Understood? Yes or no?
Yes, sir.
Next. In elements, compounds and elements. Okay. In compounds, elements are arranged in fixed. Yeah, that you have done this one. That in compounds, the elements are arranged in fixed ratio by mass. Okay. Now, can you tell me that what is the main difference between compound and mixtures? Compound and mixtures. Please note it down, and then we shall discuss this one. Please try to note the difference between. Then I will ask you, what is the difference between compound and mixtures? Then we will discuss.
Can I tell? Sir,
Yes.
sir, it is a substance in which two or more elements or compounds are mixed together simply in any proportion.
Hmm?
Sir, in mixture, it is a substance in which two or more elements or compounds are simply mixed together in uh, in not a fixed proportion.
Yeah. And in compounds, they are chemically combined together. Two or more substance are chemically combined together. Okay, in a
Yes, sir.
fixed proportion, in a fixed ratio by mass. Okay, note it down,
Yes, sir.
please.
Sir, gold is compound or element?
Gold is element.
Okay, sir. Yes, sir.
You done?
Yes.
Yes, sir.
Okay. So speak. What's the answer?
Sorry, already took.
Yes, you. Safia, can you answer me this question? Safia, can you answer me? But what is the main difference between compound and mixtures?
Sir, mixture is made up of two or more elements.
Okay,
And
not
compound is
two or more elements. Compound is also made up of two or more elements. So in mixtures, two or more substances are mixed together physically. Okay, and the constituent after the change they show their property. Constituent
Yes.
shows their property after the change. Okay, this is the main difference between the compound and the mixture. That in mixtures the constituent shows their property. Like for example, if you have a sugar solution, so in sugar is showing its property after the change also. But if you have water, so in water is made up of hydrogen and oxygen, but hydrogen is not showing its property of burning, and oxygen that help in the combustion, it is not showing the property. So
Yes.
when you even if you add water to on burning fire, it extinguishes the fire. Okay, so we can simply say that it is understood. Yes or no?
Yes, sir.
yes, sir.
Okay.
Yes, sir.
Okay. So please note it down fast.
So we have already noted, sir.
Okay, note. We have already noted. Yes. Okay. Next, let's you write two more points here. Another difference that they compounds have fixed formula, but mixtures don't have fixed formula. Okay.
Yes, sir.
Next,
Sir, I like a good example of mixture is of water and sand, right?
water and
Sand.
yeah, you can water and sand, sugar and water, salt and water. These are examples. Okay, but the compound is H2O, carbon dioxide. Okay, these are the examples of. Understood? Yes or no?
Yes, sir.
Yes, sir.
So next, uh, and the main difference is that the constant do not show their property. In mixture, in compound, the constant don't show their property, but in mixture, the constant still shows their property. Okay, okay, and they have fixed formula. They have fixed melting and boiling points and fixed composition, but mixtures don't have fixed composition, fixed formula, fixed melting and boiling point. So these are the main difference that we did in the class. If anybody who has not done this one, not written in your copy, please take, you can take the screenshot of this one so you can understand it much better. Okay,
Yes, sir. Done. Sir, I have written, sir.
So
please
we
take.
have done this.
Yes,
Okay,
sir, we wrote.
okay. So next, what do you mean by the alloys? What are alloys? Tell me, what are alloys?
Alloys.
Yes,
Alloys.
alloys are the homogeneous mixtures of two or more substance. Okay,
Sir, which alloy, sir?
which alloys, matlab?
Sir, like cars have alloy.
No, yeah, this what we called it alloys wheel because they are made up of they are not made up of especially one kinds of atoms. It is consisting of two or different kinds of metals mixed together. Okay, so that's why they are called alloys. So alloys are the homogeneous mixtures of two or more and metals and non-metal, or it can be metal or non-metal. Means they can be metal or metals and non-metals. Like copper and tin is an example. Is bronze metal. You know, bronze is not an element, not a compound. It is an alloy. Tin
Yes,
and zinc and copper is brass. Tin and lead is solder that we use for pasting in the electronical device. Okay, and carbon and iron is steel. Okay, so please note down this definition in your notebook.
yes, sir. Sir, a bell also is an alloy, right?
Which one?
A bell
Bell.
in the temples, not the doorbell.
Yeah, it is. Yeah, it is made up of brass.
Yeah, okay.
Sir, a bromine, an element or compound.
Which one?
Sir, bromine.
Bromine is an element.
Okay, sir. So that is that is brass or that is S or Z.
Hmm?
So in after bronze, it's brass or brass. Like
It
it's
is
Z
brass.
or S.
It is brass. BRASS.
Okay, sir. So should we write this? 99, 98 to 99% iron those things.
What do you say?
Sir, should we write this 98 to 99% of iron and
No,
2
no,
to
no, no,
1%?
no, no.
Oh, okay, sir. Sir, is there any substance that is present in metal and non-metal state?
Metals and non-metals mixtures allow it.
No, sir, like a substance which is present in both metal and non-metal state.
Yes, they show the property of both metals and non-metals.
Yes, sir.
There are many. They are like germanium, gallium. They show the property of both metals and non-metals. Okay, and like hydrogens too show the property of both metals and non-metals. So done this one.
Yes,
Yes,
sir.
sir, done. Done, sir.
So and why do alloys are made? Can you answer me that why do alloys are made? Why do alloys are made? Alloys
So,
are made at, in order to get a metal of a desirable requirement. For example, you need a metal which is lower in melting points. So what you are going to take it, and it is also a good conductor of heat and electricity. So you will use tin and lead. Neither the lead and not tin has like for example, lead and tin melt at 25 degrees. Sorry, tin melt at 100 degrees temperature. Let's suppose, and melt at let's suppose 150-degree temperature. Okay, this melt at 150. Let's suppose this melt at 100. So it does not mean that when you mix it, so in between the temperature is going to come. If the tin particle do not like that, like for example, tin particle is A type and the lead particle is B type. So I'm making it tin and lead. If they hate each other, at lead and tin particles hate each other. So if they hate each other, then what is going to happen is they will repel. They will not like each other, and as a result of which they will repel and they will have low melting points. So tin and lead particle don't like each other. So that's why the solder that is made by making these one is having lower melting points. And here, if I'm talking like you see that steel, why steel is so hard and dense? Actually, the iron atoms are arranged like this. Okay, and if there is no carbon atom, so they can like this one, this series of atom can slide like this way. They can come intermediate, and this result into distortion. But if you place carbon atom in between them, this is the carbon green atoms I have made. Carbon is smaller in size, so they come into its voids, and it cannot further let it to slide, and this make it to make heavy machinery. So heavy machinery like railway tracks and these are made up of iron, sorry, steel. Okay, understood?
Yes,
yes,
sir.
sir.
So alloys, like for example, if we want to make uh spacecraft, spacecraft is made up of magnesium. Alloy is magnesium, which is made up, which is consisting of aluminum and magnesium. When mixed together, they have good force of attraction. It is very means it is lighter in weight. Along we cannot make that aircraft of steel because steel is very heavy in weight.
Heavy.
So we want a metal which is also strong and but should be lighter
Heavy
in
in
weight,
weight.
lighter in weight. So
Yes.
that is magnesium. So we made aluminium and magnesium and aluminium and mixed together, they become magnesium. And this magnesium has been making the aircraft which is lighter in weight and which is having good force of attraction. So it is durable also. Okay. So according to our needs, we make the alloys. Okay.